Okay, previously we stopped at hold on, let me move my okay. Now previously we stopped at reorder point that give you this R equal to DL. Reorder point equal to demand rate per period multiplied by lead time, and we have seen one example, right? Example number 5. It is available in your tutorial handouts, right? And also we covered what is service level, what is stock out definition. And we stop at here. There's a comparison between the variable demand and with the safety stock. This one is without safety stock. This one is with safety stocks. All right, now today we learn something new with this reorder point with variable demand. Okay. Previously, in example 5, this one, we have a fixed demand D. Okay, we have fixed demand D. But what happens if the D is variable? So when your reorder point is having a variable demand, you use this equation. Yeah? So copy this one in your tutorial handouts. All right. It gives you reorder point equal to D dash. D dash means average demand. L is lead time plus safety stocks component. Right. So you already know what is safety stocks component. So safety stock equal to Z sigma D square root of L. Okay. So D hat is the average demand, and this one is daily demand. L is lead time. Z is the one that you calculate, that you learn in your mathematics statistic class, right? Z, you find the Z from the calculation. And this one is the standard variation, right? Standard variation of daily demand. Square root of L is the lead time, right? So by looking at the equation, you know that when you need to use the reorder point of variable demand, you are using statistic method. You're using statistic approach. Okay, copy this equation. R equal to D hat L plus Z sigma square root of L. This equation is for variable demand. So how to find variance? This one, variance equal to daily variance multiply the number of day of the lead time. This gives you this equation. Sigma D square L. Variance equal to daily variance multiply by number of days of lead time. You get sigma square L. So your standard variation equal to square root of your variance. Right? These two are mathematical terms that you learn in your Max 2 or advanced calculus when you calculate your statistic data, variance and standard variance. All right, square root of sigma square L. So this one, square root sigma square root, you get back the sigma. And this one L, continue with the operation square root L. Right, so variance equal to this one, standard variation equal to this one. Okay, since we're going to use statistical approach, you're going to see percentage in later calculation. Right. Okay, I assume you already copied down this equation. You already copied down what is variance. Standard variation equal to this one. So basically, if you use the information that you see on the screen here, this one is equal to this one. So basically, how do you calculate safety stock? You take the Z that you calculate from the table, right? From the statistics table, normal distribution table, Z. This one multiplied by this one is equal to standard variation. Then you get your safety stocks. So basically, you still back to this normal distribution chart here. So in fact, we have been through one of the method that we use, statistical method in chapter 3 or chapter 4. We have one chapter that use this normal distribution graph also, but in this chapter 5, we will still come back to the same approach where we need to use the normal distribution graph to find the possibility of the scenario. Okay, so this one I think I give you in your tutorial handouts. You have this one in your tutorial handouts. So basically, what is your center line of your distribution curve here is D hat L, which is here. Reorder point equal to DHL, D dash L, which is the center of your curve here. And you know that when you have a normal distributed graph, area under the curve is 100%, which is from this point up to the center, up to the last point on the graph here is 100%, but we use decimal place. So from 0 to 1 is 100%, is area under the graph. What is R? R is the numbers that you calculate. So from this graph, you calculate the percentage. Normal distribution graph, the whole graph area is 100%, which is 1. And since you're having a normal graph, normal curve, what you do, you chop the graph into half. You'll get 0.5 on the left-hand side, 0.5 on the right-hand side, like what you have been learned in the previous chapter. Okay, half of the graph is 50%, half of the graph is another 50%. Okay, so the total area under the graph is 100%. Yeah? So it depends on where is it. To the left or to the right, it depends on the situation. Okay. Okay, so this one we learned before. Let's look at example number 6. You read the statement here. In early example number 2, we assume that daily demand of the paint factory, average daily demand is 30 gallon. Standard variation is 5 gallon paint per day. Lead time receiving new order is 10 days. Determine the reorder point and safety stocks that you need to have in your factory if the store want a service level of 95%. That is probability of the stock out 5%. Basically, this last line here is the opposite meaning of 95. Okay. We already covered what is service level in the previous class. So if you don't know what is this one, go back to the previous lecture video. So what information you have here? So just now we covered a few equations there. So most of our information are available on the screen here. Your demand is given. Standard variation is given. The lead time is given. You calculate the R point and the safety stocks with the service level of 95%. Okay. First information, 30 gallon average daily demand, small d with the hat. Okay, small d with the hat is average daily demand, 30 gallon per day. Second information, lead time, capital L, 10 days. Sigma, which is the standard variation of the daily demand, here is 5. Standard variation is given 5. So for 95% service level, the store wants you to calculate service level at 95%. So you need to use the appendix A that you have in your chapter 3 or chapter 4, or even you can find in the Teams folder. All right. The Z value is 1.65. Okay. You should be familiar with this graph. This graph I explained before. This is 0. You have column, right? Column 0 until a loss of value here. We are using column 0. We are having a normal distribution. So we are only focusing on this column and this column. So where is 95%? You want to find 95%, right? So how do you get 95%? You know that the whole graph, you chop into half, 50% on the left, 50% on the right. How you get 95? 50 plus 45, right? Where is 45% on the graph here? 0.45. Huh? There's a value here, which is 0.45. Now, if you're not familiar with this one, please go back to your mathematics class textbook. This falls under statistics chapter. Go back to your Max 2 textbook, or if you're really lost in this chapter, go back to your mathematics lecture. Ask your lecturer what is normal distribution data, how to find normal distribution. In fact, this one was come out in the national secondary school exam. Okay, so since you already passed the minimum entry requirement, we assume you already know how to use this chart already. Okay, so if you don't know, we have to send you back to year 1. Huh? Because you don't have the foundation, we have to send you back to the year 1. All right. So the question gives you one condition. The store 95%. Okay. So again, area under the graph is a probability. You need to find 95%. So half of the graph is 50%. Another half is 50%. So you want to find 50 plus 45. Where is 45%? You look into this one is from 0% to 50%. So you find 45% in this table. So where is 45? You go to around here. I put it very big on the screen here. Where is 45? It is around here. Okay. What does this means? This is 0.4452. It means 44.52%. What mean by 45.54? It means 45.54%. What mean by 0.4772? It means 47.72%. The question asks you to find 95%. You already know half of the graph is 50%. You need to find another half, which is here, 45%. Whereas 45 is about here. You need to do interpolation, which is in between 1.6 to 1.7. You're having two numbers here. Do interpolation to find 95%, to find 45% over here. Okay. How to do interpolation? That is fall under mathematics 1 or even in your secondary school government exam. Okay. So it's here. You need to do interpolation. Find the Z value over here. This column is your Z value. You need to find what is your Z value. So your Z value, you do interpolation, you get 1.65. Okay. Darshan, are you here? Guru Darshan? Okay, hold on. Let me send the text. Guru Darshan, are you here?
Yes, sir.
Okay. Guru Darshan, explain how you get 1.65.
Using interpolation, sir.
Okay, good. All right. So we are very clear how to get interpolation. Okay, so those don't know one, go and ask Guru Darshan. Okay, I did explain how to get z equal to 1.65. You know that the safety stock equal to z sigma square root of L. Okay, safety stock equal to z sigma square root of L. You already get your z from the appendix or from the normal distribution table. Sigma is given 5. Lead time 10, you square root it. Okay, help us to calculate this one. Sarini, sorry, yeah, Sarini, are you there? Sarini, help us to calculate what is the safety stock. Sarini, are you there? Calling Sarini. Calling Sarini second time. I'm texting Sarini. If no response, consider absent in my class for the record. Okay, WhatsApp text sent out. If Sarini do not respond within 3 minutes, consider absent. Calling Sarini. So Sarini, no excuse. This video is real-time recorded. I've called you more than 3 times. You do not respond. Okay, next I'm calling for Ruven. Ruven, are you there?
Hello, sir. Sorry, sir. I was went to the washroom.
Ruven, help us to solve this question.
Answer is 26.09.
26.09. You round up to 1. So of course you can use 26.01 Garen in your calculation. Maximum 3 decimal place, minimum 2 decimal place, or sometimes 1 is enough for this module. For engineering module, minimum 2, but for this module, 1 decimal place is enough. Okay, so you define your safety stocks. You're very clear for the first session, right? For the first safety stocks here. All right, so you have the calculation here. R equal to D bar L plus Z means plus the safety stock component. Okay, Sarini, I'll give you a chance to solve this question. Give us the answer for reorder point.
300 plus 26.1. So 326.1.
326.1 gallon. Huh? All right, good. Okay, so this is how you solve and you apply for variable demand. Huh? Means that if you are seen in a question, you've seen standard variation is given, meaning it straight away it fall direct under variable demand. Okay, very direct, very direct, and even it give you a service level of how many percent. That one sure confirm fall under variable demand because you given percentage of service level, you need to use the distribution graph. You need this formula. Okay, this formula fall under variable demand. Any question before we move forward? Any question to solve example number 6?
All okay, sir.
Good, eh? Okay, move on. Next, we look at order quantity for a periodic inventory system. Now, previously when we enter, I think in chapter 4, we have seen the behavior of demand, right? You have trend, and then you have periodic, right? You have seasonal, you have cycle. Now we look at what happens if you have periodic inventory system, right? This one, a remark here. A periodic inventory system normally require a larger safety stock here. So you already know how to calculate safety stocks already, all right? You already know how to calculate safety stocks. Just now, this one was calculated by Reuven, all right? So the same formula you already have already, but the number should be bigger if you are going to solve for periodic inventory system. Okay, this one you can read. So for periodic one scenario is that they will fall under low value, larger safety stocks. Means they are under category C item. We learned about ABC system before. Item A, item B, item C. Normally, this one is more suitable for item C system, yeah? Inventory system. Okay. Let's look at order quantity with variable demand. Okay. First, order size changes. The order size changes. You're going to use this lengthy equation. Copy this equation. This equation is for order quantity with variable demand. Okay. If you see variable demand, it means you need to use the normal distribution graph or normal distribution table again. Variable demand means you need to use statistical approach. Here, you modify a little bit from the previous equation, the reorder equation, you modify a little bit, right? So I'm not going to explain about how the derivation about this one, but you're more focusing on application of equation. So Q is the order size equal to D dash, which is the average demand, TB plus L. Okay, and the last one, this one, Z sigma square root of TB plus L, this is your safety stocks, minus I, this is not 1, capital I, is capital I. So I give you the definition of all these parameters. TB is a fixed time between the orders. TB is a time between your order. I is inventory in stock. Okay. I is inventory in stock. This one. So when you calculate order quantity, you need to consider how many stock you have in your inventory. There's an inventory component here. Copy this one. This is for order quantity with variable demand. Q equal to this one plus your safety stocks minus inventory. What is the first component here? First component here is amount of inventory that you need, to protect, to so that you serve at the particular service level. Okay. So this is an amount that you must have in the inventory. Okay, you can see this component, red color one, is a must have, the quantity that you must have in hand while waiting for your order to come. Okay, so the must have quantity plus safety stocks minus the inventory is your order size. Okay, so you also have this graph in your handouts, right? So you can see that the versus the y-axis is your inventory. The x-axis here is the time. So what is the pattern of this graph? You observe the red color line. The demand go up and down. It fall under variable demand. Go up and down, and then here up again. Okay. So this kind of pattern is fall under variable demand. So this is your safety stocks. Okay. Again, what is the purpose of safety stocks? It to eliminate the negative demand here. Is to eliminate the stock out. This is, you have experienced stock out. If you don't have the safety stocks, your customer going to be very angry with you because they cannot get the stock on time. This is a negative. Means no more stock in the warehouse already. But how to avoid this one? You have a safety stock just to make sure there is a service level there. Means your customer always have item to handle. We already explained about the lead time. We also calculate the lead time before, and all the points we already covered in the previous lecture. All right. Okay. So you have this one. You just study a little bit more during your revision time. Now we look at application of this equation. So you read for a while this statement. A pharmacy is going to stock up a very popular brand at a counter for flu and cold medicine. Average demand is 6 packages per day with the standard variation 1.2. So you're given standard variation here. The vendor or pharmacy company check the stock every 16 days, 60 days. All right. So during one visit, the store had 8 packets in the store. The lead time to receive an order is 5 days. Determine the order size for this period that will enable the pharmacist to maintain service level 95%. Okay, so in example number 6, we already know how to calculate service level at 95%. Use the same approach. Use the same approach to find your Z by using the normal distribution table. All right. So what information we have? We have all this information. D dash, which is your average demand, daily average demand, which is 6 packets per day. Lead time 5 days. Here. Your standard variation 1.2. Here. Standard variation given. T sub B, fixed time between the order, you need 60 days. This one. because your supplier go into your store and update your order every 60 days. So it fall under TB. So this is something new for today. TB, 60 days. I is your inventory. So in your inventory, during the supplier go into the stock, you check every 60 days, there is a 8 package there in the stock. So this one fall under inventory stock 8 package. Okay. So you have the D dash L sigma T sub B I by using the equation that we learned 5 minutes ago. Right? So you know that 95%, we already explained how to use the appendix A by finding the Z equal to 1.65 just now, right? And the equation that we just learned, Q equal to this one plus the safety stocks minus inventory. You have this one, you have this one, you have this one, you have this one, you have the Z from the table. Okay. L is given, TB is given, D dash is given. You manage to find the Q. Okay. Let's ask for help, someone in the class. Muti, are you there? Tashna Muti? Okay, while we're texting Muti, let Hari Prasad. Hari Prasad, can you help us to calculate what is the Q? While I'm texting Muti.
Okay, sir.
The rest you can also double check. Double check Hari Prasad answer later.
Sir, 397.96.
300.
97.96.
Okay. 397.96 package. This is your order size. Okay. So of course, when you order, you round up lah. This one is very near to 8, so you round up to 398 packet. Right. So or maybe in the real case, sometimes they deliver like one parcel or one package, one delivery. When they pack the medicine, they pack maybe in one shipment is about 40 packet. So you follow the minimum package order, right? So this is this green color is more realistic answer after you find out point something. Okay, for order size of fixed period model, when you calculate, right, you still need to give me point something, but you have to come up with a conclusion. The Q value should be round up to the round number. For example, 397.96 round up to 398, and then sometimes the question will add in at the last line here. The question might be give you extra information. If the shipment come with a minimum, if the shipment come with one parcel 400 medicine per shipment, how many the pharmacies should be ordered? So the answer is 400. Okay, it depends on the statement. So this one the last statement here is more on the reality or real life. When you work outside there, you need to follow the shipment or how they pack the thing when they ship the things. So somehow they come in the box, maybe one box have 50. Then the more flexible you have, all right. Sometimes it come by 10. It depends on the size, right? Sometimes it come by 100. It depends on, again, how they pack the things. Okay, so just take note on this. When you go out to work, you need to consider the shipment condition. Okay, so with this, we conclude chapter 5 here, and then we go for a short break. We go into chapter 6 after the short break. Okay, tutorial handouts for chapter 6 is available. You can download from Teams. Let me end the recording.